Hi, Geo. So this is the last lesson ever for the year. We are doing lesson 6, which is systems of equations in geometry. So you did systems of equations last year in algebra. I'm going to review that with you now, both different kinds. There's two methods, substitution and elimination. And next year you're going to do the same thing, but you're actually going to have 3 equations and 3 variables. When you did it last year, you just had 2 equations and 2 variables. So a system of equations is a set of equations that are solved collectively together. So you're basically solving them at the same time. The basic linear system is composed of 2 linear equations with 2 variables. There are 2 basic methods of solving linear systems algebraically, substitution and elimination. So we'll do the substitution here. Substitution, the goal of the substitution is to completely eliminate one of the 2 variables in the linear system by replacing it with an equivalent expression. This goal is accomplished by solving for one variable from one equation and plugging it into the other equation. So basically, when we have a system of equations, like if you look at this example, 2x minus y equals 0 and 5x minus 2y equals 3, I can't solve these individually because they're 2 variables, x and y. But if I solve them together, I can get one of the variables to drop out. So the method that I'm going to use here is substitution. So the first thing that I need to do is you need to solve one of the equations for either the x or the y. Which equation you pick, you get to decide, but we want to try and pick the easier one to solve. Keep this as simple as possible. So this equation solves the first equation for y. So I took this first equation, 2x minus y equals 0, and I solved for y. All I did was I brought this y over to the right. Okay, so it's right here, 2x minus y equals 0. I brought the y over to the right by adding y, and I get y equals 2x or y equals 2x. 2x equals y, but I can flip that around and write y equals 2x. So now that I know that y equals 2x, I'm going to replace the y in the second equation with what you found y to equal. So I'm going to take, let me just grab my highlighter right here. I'm going to take this y in the second equation, and now that I know y equals 2x, I'm going to substitute 2x in for the y. So I took the first equation and I solved for y, and now that I know y equals 2x, I'm going to take that second equation, which was 5x minus 2y equals 3, but instead of the y, you can see right here, I'm substituting in 2x because that's equivalent of what y is equal to. So now solve this new equation. So I have 5x, I take that negative 2 and I distribute it to the 2x, so 5x minus 4x equals 3. 5x minus 4x is really just 1x or x, so x equals 3. Now, once you solve for one of the variables, the last part is very easy. You just go back to either equation. It does not matter which one. And I'm just reading this rule here. You substitute this x value into either of the original equations and solve for y, and now you've solved for both x and y. So they took the first equation, 2x minus y equals 0, and now that I know that x is 3, I'm substituting 3 in for x, and 2 times 3 is 6, and I'm going to solve for y, so y equals 6. So those are my two answers, x equals 3 and y equals 6. All right, so let's try one together. Then we're going to go over the elimination method, and then we will try these with actual geometry problems. So these are my two equations, y equals x plus 7, y equals negative 2x plus 1. I'm going to take this equation, y equals x plus 7, but now that I know that y is equal to negative 2x plus 1, I am going to substitute that right there. So I'm going to take, instead of y, I'm going to have negative 2x plus 1 equals x plus 7. So I've eliminated one of the variables, and I'm going to solve for x. So I'm going to take this negative 2x, and I'm going to bring that over to the other side by adding 2x, and then I'm going to take this 7, and I'm going to subtract 7, and I'm going to have 3x equals negative 6. Okay, so this is just a regular equation that you're solving, and I'm going to solve for x, so I have to divide by 3, and x equals negative 2. Now that you know what one of the variables are, you can go back to either equation. I always go back to the easier one. The easier one to me is this one, y equals x plus 7. So I'm going to take y equals x plus 7, And now that I know that x equals -2, I'm just substituting in -2 for x. So y equals -2 plus 7, and -2 plus 7 is 5. Okay? Next page, let's just review with you the elimination method. So the goal of the elimination method is to create a situation where one set of the variables will cancel each other out when the equations are either added or subtracted. It may be necessary to create coefficients for these variables that are the same to make the cancellation possible. This creation process is accomplished by multiplying through the equations. So here I go, nice easy one to try. X plus y equals 12 and 2x minus y equals -6. The first thing that you have to do is you have to make sure the x's are lined up underneath each other, the y's are lined up, and then just those numbers are lined up. So before you begin, be sure the variables and constants are lined up one under the other. If you need to, you would rearrange. So now that they're lined up underneath each other, you want either the x's or the y's to cancel out. The only way that's going to happen is if the coefficients are the same. Now, this is a 1x and this is a 2x. This is a 1y and this is a -1y. So basically, the easiest thing is in this case is to have the y's cancel out. I don't even need to multiply to change these coefficients because the y's already have the coefficients. And as long as the signs are either the same or different, they will cancel out. Since the signs are different, they're going to cancel out by adding. If the signs were the same, then you would have to subtract. Okay, so the variables in this example are already lined up. So let's begin. Decide which variable, x or y, would be easier to cancel or eliminate. In order for that to work, the coefficients of the variables, the coefficients of the numbers in front must be the same or negatives of one another. In this example, the y values will most easily cancel out one another when the equations are added. So I'm going to take these two equations and I'm going to add them together. Now, when I do that, x plus 2x is 3x. Y plus -y, these cancel out. 12 plus -6 is 6. I solve for x, I divide by 3, x equals 2. Once I solve for one of the variables, you just go back to either equation, it doesn't matter which one, and substitute 2 in for x. So I went back to the equation x plus y equals 12. I'm substituting in 2 for x, and I'm going to solve for y equals 10. All right, so let's try one. Let's solve the linear system of equations algebraically using the elimination method. Remember to first multiply to make the coefficients of the x's or y's the same. So if you look, this only works if the coefficients of the x or the y are the same. This is 1x, this is 2x. This is 2y, this is -1y. So I'm going to make the y's be the same. Now, the way that I can easily make these y's be the same is if I take this second equation and multiply the whole entire thing by 2. Okay, because that will make this a -2y. And if this is a positive 2y and this is a -2y, when I add the equations, those y's will drop out. Your goal is to only have one variable. You can only solve for one variable at a time. All right, so this x plus 2y equals 12 stays exactly the same. I'm not doing anything. I'm taking this second equation and multiplying the whole thing by 2. 2 times 2x is 4x. 2 times -2 is -2y, and 2 times 4 is 8. Now that these are the same, I'm going to add these equations together. X plus 4x is 5x. 2y plus -2y, well, those cancel out. And 12 plus 8 is 20. These cancel out right here. All right, so I'm adding these two equations together. And I get 5x equals 20. I'm solving for x, so I need to divide by 5, and I get x equals 4. Now I can go back to either equation, it doesn't matter which one, and I'm going to substitute in 4 for x, and now I'm going to solve for y. So you're basically solving for one variable at a time. I'm taking the first equation, it just looks a little bit easier. X plus 2y equals 12, and I'm going to substitute in 4 for x. So I'm going to take this 4, and I'm going to substitute it right in here for x. So I'm going to have 4 plus 2y equals 12. Now I'm solving for y, so you got to subtract 4, and I'm going to get 2y equals 8. Then I'm going to divide by 2 because I need to solve for y, and I get y equals 4. All right, so when you do this next year in Algebra 2, you're going to have 3 equations because you're going to have 3 variables, x, y, and z, and it's just going to be a little bit more involved. So that's why I wanted to go over it. Let's try 2 geometry problems. So the first thing you have to do is you have to come up with the equations. Now these are vertical lines. Remember vertical angles, these are vertical, not vertical lines, vertical angles. Vertical angles are equal to each other. So these angles right here are vertical angles, they're equal to each other. And 2x plus y plus 8 is equal to 58. So the rule that we learned this year in geometry is that vertical angles are congruent. So I'm going to write 2 equations. First one is x plus y equals 35. And the second one is 2x plus y plus 8 equals 58. Now I need to line everything up nicely. The x's are lined up, the y's are lined up, and the number on the first equation is on the right. So I'm going to subtract 8 and move that over to the other side. And I'm going to have 2x plus y equals 50. So all I did is I took this 8 and I subtracted it and I brought it over to the right so that everything is lined up nicely. Okay, now the y's have the same coefficient 1, so I do not need to multiply. What I'm actually going to do is I'm going to subtract. Okay, so I'm going to take this whole second equation and I'm going to subtract. So x minus 2x is going to give me negative 1x. Y minus y is actually going to cancel, so these will be gone. And 35 minus 50 is negative 15. So I subtracted, since they had the same coefficient, but they also had the same sign, I subtracted that second equation. Remember, you're subtracting everything. So that's why I added the parentheses and that subtraction sign. Now I'm solving for x, so I'm going to divide by negative 1. So my answer is just x equals 15. Now, once you know what one of the variables is, it's very easy to go back and solve for the other variable. You pick either equation. The first equation, x plus y equals 35, is a little bit simpler. Now that I know that x is equal to 15, I'm going to take that and I'm going to substitute in 15 for x. So 15 plus y equals 35. And again, I'm solving for y, so I'm going to subtract 15, and I'm going to get y equals 20. Okay, and then we have this one here. So if you want to pause the video and you want to try this on your own and then restart it, you can do that. Here I have some parallel lines. Again, you're writing 2 equations. You have to remember the rule that same side interior angles are supplementary. Now, supplementary means that they add up to 180. So these 2 angles are supplementary, and these 2 angles are supplementary. So you have to write the equations yourself. I'm going to take x plus y plus 125 equals 180. Then I'm going to take x minus y plus 145 equals 180. So those are my 2 equations. Now bring anything that's a number over to the right. So I'm going to subtract 125. The x and the y are perfect right where they are. So I'm going to leave the x and the y, and I'm going to subtract 125. So x plus y equals 55. Same thing for the second equation. Leave the x, leave the negative y, but subtract 145. 180 minus 145 is 35. Now these are actually perfect because this is a positive 1y and a negative 1y. So if you go to add these equations together, okay, so I'm going to add them, the y's will drop out. So x plus x is 2x, but y plus negative y is gone. And then 55 plus 35 is 90. So again, x plus x is 2x. 55 plus 35 is 90. Now you have to solve for x. The whole idea is to eliminate one of the variables so that you can solve for either one. In this case, we eliminated the y, so now I'm solving for x. I divide by 2, x is 45. Once you solve for one of the variables, then you just pick either equation. It doesn't matter which one. All right, I took this x, I actually took the one that I simplified a little, x plus y equals 55. And you know that x is equal to 45. So I'm going to take that 45 that x is equal to and substitute it in. 45 plus y equals 55. And then I'm solving for y, so I'm going to subtract 45 from both sides, and I get y equals 10. Okay? And that's it. That's your last lesson. There's one more practice on Delta Math to do, and then anything that you're missing, you can work out as well.